Greetings to everyone. In this video, we will discuss about some major factors in water quality. Ozonation treatment in drinking water, method of removal of dissolved inorganic contaminants in water, and effects of acid mine drainage in the environmental water. Drinking water is important in our daily life, and it can be treated using different processes. Treatment of water starts from primary treatment plant, where screening of water is taking place, to secondary treatment plant, where bacteria and viruses are being treated, and then to tertiary treatment, where the wastewater quality is improved before it is reused, recycled, or discharged to the environment. One of the processes used to disinfect water is ozonation, which is simply the formation of oxygen into ozone using energy. Although disinfected water with ozone cannot be considered as the last step, but it is very necessary to do. An ozonation system can occur by passing dry clean air through a high voltage electric discharge as corona discharge, which creates an ozone concentration of approximately 1%. For small quantities of waste or low concentration of ozone, the ultraviolet ozonation is generally used. An ozonation test is required at this stage. At the end of the ozonation test, the raw water is then passed through a venturi throat, which creates a vacuum and pulls the ozone gas into the water. Post-filtration is required as the ozone will react with metals to create insoluble metal oxides. Ozone is an inorganic molecule in an allotropic form of oxygen. It is a blue pale gas with a pungent odor. The main reason why we disinfect our drinking water with ozone is to kill bacteria and viruses, as well as other microorganisms that might exist in our water. What happens is that the water is compressed with ozone gas, which breaks down all organic matters in the water into pieces, and this results in no risk of those microorganisms in growing up or immunity. This process happens in the secondary treatment plant before being transferred into the tertiary treatment plant. By doing this process, it improves the color and the taste of our water. Ozonation is popular and widely used in South Africa, as it is easier compared to other processes such as chlorination. As an example, ozone is 51% stronger than chlorine and has a time faster kill rate. The gas used in the ozonation can be generated outside. The treatment process does not add any chemicals to the water, and ozone is effect over a wide pH range. It can eliminate a wide variety of inorganic, organic, and microbiological problems.
Inorganic contaminants like arsenic acid, iron, chromium, and manganese occur in nature, and they often end up in the surface of groundwater. Some of these contaminants are as a result of man-made pollution, others from interaction between nature and pollution. These contaminants, they affect the quality of water, such as the taste, the smell, and the color. There are ways in which we can remove these dissolved inorganic contaminants from water. Reverse osmosis. In this process, contaminants are removed by forcing pressure on water through a synthetic membrane. This membrane contains microscopic pores that allows only water to pass through, leaving other things behind. We know that molecules of dissolved metals and salt are large compared to water molecules. So the water squeezes through this membrane, leaving behind the metal and the salts. Distillation. This process involves boiling water to a certain boiling point to produce water vapor. The vapor will rise up to a cool surface where it condenses back into a liquid form. The dissolved salts and contaminants are unable to evaporate, and then they will remain in the boiling solution. Deionization. Through deionization, we get deionized water. In the process of deionization, water is passed through a positive and a negative electrode. There is an ion selective membrane here that will allow ion to pass through, separating the ions from water. The end result, it will be deionized water, of course, and then the deionized water is pure, or the deionized water has high purity. But the water has to pass through reverse osmosis first in order to remove non-ionic contaminants. The last method we are going to talk about is softening of water through ion exchange. Presence of inorganic contaminants such as magnesium and calcium in carbonates and sulfate can result in the hardness of water. This process helps us to soften water. In this process, there are 3 sections according to the diagram. Then there's an ion exchanger section, there's a cation exchanger section, and then there's a section that has steam jackets. In the cation exchanger section, that's where cation exchange reaction takes place in order to remove ions. In the anion exchanger reaction takes place to remove acids. And then the water that is free from ion and acid will leave this section and will go to the chamber. This chamber has steam jackets. Those steam jackets, they contain tubes of higher temperature and pressure. The higher temperature and pressure help so that carbon dioxide cannot dissolve in the water.
The effect of acid mine drainage in an environmental water. Acid mine drainage is the flow of water out of a mine that has very low pH after being in contact with air and metal. Acid mine drainage becomes apparent primarily when the mineral, fool's gold or iron sulfide, comes in contact with oxygenated water. The purite goes through oxidation in a process of 2 stages. The first stage producing sulfuric acid and ferrous sulfate, and the second stage produces orange-red ferric hydroxide and more sulfuric acid. Acid mine drainage decreases the pH of water, and this affects the ecosystem severely. The fish, animals, and plants that uses the water will eventually die. The lower the pH in the water, the higher the concentrations of toxic metals, and it's very harmful to the organisms living in the water and the ones using the water. The ability of water to be used is also reduced, and this also causes corrosion to infrastructure such as bridges. The impact of acid mine drainage is different because it depends on geomorphology, the climate, and also the distribution and the extent of the acid mine drainage generating deposit. To reduce the acid mine drainage, neutralization process needs to be done in the mines by adding lime or other alkaline materials such as hydroxide and ion binding compounds. This reduces the pyrite oxidation and the metal mobility. In overall, the treatment of drinking water is a vital factor to take into consideration in order to have a pure drinking water.